Imagine a galaxy you can't really see, not because it's far away, not because it's behind dust, but because it has almost no stars. And yet, something out there is still acting like a galaxy. It's pulling on its surroundings, shaping space around it, and leaving clues that scream mass. This is the kind of discovery that makes astronomers uncomfortable, because it forces one question. If a galaxy can exist without the thing that makes galaxies visible, how many more are out there, hiding in the dark? Tonight, we're going to track the evidence for a ghost galaxy, how it was spotted, why it shouldn't exist, and the one explanation that turns the whole universe into a much stranger place. Okay, when we say ghost galaxy, we're not saying it's literally empty. We're saying something way weirder. It has so few stars that on a normal telescope image, you could stare right at it and never realize it's there. Because a typical galaxy announces itself. It's bright, it's crowded, it has structure, arms, a core, clusters. This thing doesn't. So the first reaction is obvious. Maybe it's not a galaxy at all. Maybe it's just nothing. But then the clues show up. Clues you can't fake. Something is moving like it's orbiting a hidden mass. Or light is bending like there's a gravitational object in the way. Or gas clouds are behaving like they're trapped in a deep gravitational well. And that's when the definition of galaxy becomes uncomfortable. Because a galaxy isn't just a bunch of stars. A galaxy is a gravity system, a structure held together by mass. Stars are usually how we see that structure, but what if the structure exists first and the stars are optional? That's the nightmare hidden inside this discovery. It suggests there can be real galaxies out there, massive ones, that are basically invisible to us. And if that's true, then what we call the map of the universe might be missing a whole category of objects. Now here's the key question. How do you prove something is a galaxy when it barely has stars? You don't look for light, you look for effects. Because even if a galaxy is almost invisible, its gravity still does the same three things every galaxy does. It pulls, it bends, it traps. First, it pulls. If there are any nearby objects, tiny star clusters, gas clouds, even a few lonely stars, you can track their motion. If they're orbiting, then something massive is there. Second, it bends light. Gravity doesn't just pull objects, it distorts space itself. So if there's a background of galaxies behind it, the ghost can slightly warp their shapes, like a weak lens. It's subtle, but it's measurable. Third, it traps gas. Even if stars are missing, gas can still gather in a deep gravitational well. And gas is loud, just not invisible light. In radio, it can glow. In certain wavelengths, it leaves fingerprints. So the way this gets discovered is usually the same story. At first, astronomers notice something that makes no sense. Motions that look like an orbit, or lensing that hints at mass, or gas behaving like it's sitting inside a galaxy. And then they point better instruments at it. And what they find is the most unsettling kind of confirmation. There's a galaxy-sized gravity well, with almost nothing shining inside it. Which leads to the next question, the one that makes this ghost galaxy feel like a threat. Where did the stars go? Or worse, what if they never formed in the first place? Okay, so how does a galaxy end up like this? A massive gravitational container with almost nothing inside it. There are a few explanations scientists take seriously, and each one is unsettling in a different way. Theory 1. It's a failed galaxy. In the early universe, a clump of dark matter forms first, like the frame of a house. Normally, gas falls in, cools down and stars ignite. But if something disrupts that early process, strong radiation, violent heating, or gas being stripped away, you can get a dark matter halo that never turns on. It's a galaxy that was supposed to exist, but never lit up. Theory 2. It was robbed. This one is colder. A galaxy drifts too close to something bigger, a massive neighbor, a cluster, a tidal environment, and it gets ripped. Not just a little. Stars get pulled out, stolen, scattered, and what's left behind is the invisible skeleton, gravity without the glow. Theory 3. The stars are there, but they're hiding. This is rare, but possible. Some galaxies are so faint, so spread out, and so low density that they almost disappear into the background noise. If the stars are extremely old, extremely dim, and spread wide, you might think there are no stars, when it's really almost impossible to see them. But here's the problem. For some of these ghost galaxy candidates, even when astronomers go deeper, even when they use better surveys, the light still doesn't show up the way it should, which leads to the most uncomfortable idea. Theory 4. It's mostly dark matter, and that's the point. If a galaxy can exist with almost no stars, then the thing we call a galaxy isn't really a city of stars at all. It's a dark matter structure that sometimes happens to make stars, meaning the universe could be filled with invisible galaxies we've never counted. Not a few. Potentially millions. And if that's true, then our map of the universe, the one we've built from light, is missing a huge fraction of what's actually out there. So now we've reached the turning point. This isn't just a weird object, it's a warning. Because the moment you accept one ghost galaxy is real, you have to ask the next question. How many more are hiding in the dark? Here's why this matters so much. Astronomers don't just study galaxies for fun. Galaxies are how we count the universe. We look at light, we map where galaxies are, and from that, we estimate how matter is distributed. But if there are real galaxies out there with almost no stars, then we've been doing a kind of census using only streetlights. We're measuring a city by counting the lit windows. Now, there's already a famous tension here. Simulations of the universe, especially the ones built on dark matter, often predict more small galaxies than we actually observe. For years, people argued about that. Maybe our simulations are wrong. Maybe our physics is missing something. Maybe we're misunderstanding how galaxies form. But a ghost galaxy changes the argument. Because it suggests a brutal possibility. The missing galaxies might not be missing at all. They might just be dark. They exist as gravitational structures, but they never formed many stars. Or they lost them. Or they're so faint we don't notice them. And that would ripple into everything. It would change how we estimate total matter in different regions. It would affect how we interpret the growth of galaxies over cosmic time. It would change our assumptions about how easily star formation turns on. And it would mean the universe is more crowded than it looks. But here's the best part, and the most dangerous part. This isn't just philosophy. A ghost galaxy makes specific predictions. If it's real, it should still interact with other things. It should still tug on gas. It should still bend light. It should still leave fingerprints. Which means we don't have to argue forever. We can test it. So now the story shifts from, is it possible? To, how do we prove it beyond doubt? All right, so what would convince scientists this is a real ghost galaxy and not a mistake? They look for three kinds of proof. Test 1. A gravity signature you can't fake. If nearby objects are orbiting, or if gas is moving too fast for the visible stars to explain, that's a mass problem. The faster something orbits, the deeper the gravitational well has to be. So if the motion says galaxy, but the light says almost nothing, then something unseen is doing the heavy lifting. Test 2. Lensing, the universe's lie detector. This one is slow and subtle, but powerful. If there are distant galaxies behind the ghost galaxy, its gravity should slightly warp their shapes. Not a dramatic ring, more like a consistent, tiny distortion. It's hard to detect, but if the distortion pattern repeats across many background objects, that's the kind of evidence that doesn't care about opinions. Test 3. Gas fingerprints. Even if stars are missing, gas can still reveal the structure. Astronomers can look for cold hydrogen or other signatures that show gas sitting inside a massive halo. And here's the key. If the gas is there and behaves like it's trapped, but the stars are missing, then the galaxy isn't invisible because it's empty. It's invisible because it's dark. Now, what would falsify it? Simple. If deeper imaging finds a normal population of faint stars, then it's not a ghost galaxy, just a very faint one. Or if better data shows the motion was misread, then the mass vanishes. That's why this field is exciting right now, because the tests are getting better. Deeper surveys, better measurements, more precise lensing maps. The universe is basically being scanned with a stronger flashlight, and what we're learning is the dark parts might be full of structure, which brings us to the final question, the one that makes this story bigger than a single object. If ghost galaxies exist, what else have we missed by only trusting light? Here's the part that changes how you look at the night sky. When you stare into space, you feel like you're seeing the universe, but you're not. You're seeing the parts that glow. A ghost galaxy is proof of something we already suspected, but rarely feel emotionally. The universe is not made of what's visible. It's made of what has gravity. And if a galaxy can exist with almost no stars, then the biggest structures in the universe could be surrounded by invisible neighbors, dark halos, failed galaxies, starless systems, quietly shaping everything around them. So the real mystery isn't just, did we find one ghost galaxy?
Makes up the majority
It's
of our universe.
how many are out
other
there,
secrets does the
hiding in the
darkness
dark, right now? Because if the answer is a lot, then our maps of the cosmos are incomplete. Our counts are wrong. Our assumptions about galaxy formation are missing a chapter. And the universe is more crowded, more structured than it looks. And that's why this discovery matters. Not because it's spooky, but because it suggests the sky is full of objects we've never learned how to see. Now I want you to answer one question in the comments. If you could point a perfect telescope anywhere, would you search for ghost galaxies? Or would you search for what might be hiding inside them? Because in the next video, we're going one level deeper into the invisible structures that control what the universe becomes.